All right, let's talk SQL. If you've got the basics down, you're probably ready to move past just fetching data. Today, we're diving into the good stuff, how you ask the really complex questions and get those powerful insights that are hiding in your data. Let's get to it. Okay, so picture this. Your database has millions, maybe even billions of rows. You know the answers are in there, but just running select all, well, that's not going to cut it, right? So how do you actually find the gold hidden inside that mountain of data? That's exactly what we're going to break down today. Here's a quick look at where we're headed. We'll kick things off with summarizing your data. Then we'll get into grouping for deeper insights. After that, we'll filter those groups, tackle queries inside of other queries, and wrap up with how to write smarter, cleaner SQL. Each step builds right on top of the last. All right, first things first. We've got to talk about the absolute foundation of any real data analysis. It's all about taking these massive, overwhelming lists of numbers and just boiling them down into something simple and meaningful. We're talking about condensing all that noise into a single, useful number. And the main tools for this job? They're called aggregate functions. You can pretty much think of them as super-powered calculators. Instead of working on one or two numbers, they take an entire column of values, crunch them all at once, and hand you back one single summary value. Now, you've probably already met the big five of aggregation, right? We're talking average, min, max, sum, and of course count. These are your absolute workhorses for turning thousands of rows into a number you can actually work with. Let's see a quick example to get us warmed up. So let's say someone asks a simple question. What's the average salary for the computer science department? Easy enough. You just use the av function on the salary column and then use a where clause to look at just the comp sci folks. Boom. One clean, simple answer. But, a single number is, well, it's just a starting point. The real power comes when you can start comparing things. That's when you go from just summarizing data to actually analyzing it. Because the next question is obvious, isn't it? Okay, the comp sci average is great, but what about the average salary by department? You want to know how it stacks up against physics or history or finance. And that simple query we just ran, it can't do that. We need something more. And that's where the group by clause comes in. It's an absolute game changer. What it does is it tells SQL, hold on a second. Before you calculate that average, I want you to first sort all the rows into different buckets based on, say, their department name. Then you can run the average calculation on each one of those buckets separately. So check this out. By just adding group by department name, we totally change what we get back. We're not getting one number anymore. We're getting a list, each department with its own specific average salary right next to it. Suddenly, you have this incredibly powerful way to compare everything at a glance. Okay, this is great. Now we've got our list of departments and their average salaries all laid out. So what's next? Well, the next logical thing to do is to start filtering these groups to find the really interesting ones, the outliers. So you might get a question like, can we only see the departments where the average salary is above, say, $42,000? And this is where a lot of people get tripped up. Your first instinct might be to use a where clause, but you can't. A where clause just doesn't work on the result of an aggregate function like avg salary. So what do? You use the having clause. This thing was literally invented for this exact scenario. It always comes after your group by, and its whole job is to filter the results after all the grouping and aggregating is done. This is probably one of the most important distinctions to get right. Let's break it down. The where clause is like a bouncer at the door. It filters individual rows before they even get into the party, before they're grouped. Having is like the host kicking people out after the party started. It filters the entire groups after they've been formed and calculated. The order of operations is absolutely crucial here. All right, time to level up again. Some questions you want to ask aren't just one step. They're more like a two-step process. You need to find the answer to one question first, just so you can use it to ask the next question. And that's where we get into the world of subqueries, nesting one query right inside another. Take a look at this question. How do we find the student with the single highest score? On the surface, that sounds super easy, right? You'd think you could just say, select the student where their score is the max score. But nope. Try to write that and SQL will throw an error. And this is that wall I was talking about. You'll get an error that says something like, group function is not allowed here. And the reason is pretty logical when you think about it. The where clause looks at each row one by one. But the max function needs to look at the entire column all at once to find the maximum value. They're trying to do two different things at the same time, and it just doesn't work. So the way around this is to use a subquery. It's exactly what it sounds like, a select from where query that's nested inside another one. The key is how it runs. The inner query goes first. It does its job, finds a single value, like the max score, and then it just hands that number over to the outer query, which can then use it. So it's a simple two-step dance. Step 1. The inner query, the one in parentheses, runs all by itself. It scans the table and finds the highest score is, for example, 70. Step 2. The outer query now effectively reads select star from new student 1 where M3 equals 70. The subquery is gone, replaced by its result, and it becomes a really simple query to execute.
Okay, so subqueries are incredibly powerful, but let's be honest, they can get messy. When you start nesting queries inside of queries, readability can go right out the window. So for our last section, let's talk about a much cleaner, smarter way to write complex SQL. Here's an example of a nested query. You can see we've got a whole select statement right there in the from clause. Now, this totally works, but you have to admit, it's kind of tough to read. You have to find the innermost parentheses and mentally work your way out. It's just not intuitive.
Okay, now look at this version. This is the cleaner way, using a with clause. What we've done is taken that entire subquery, pulled it out to the top, and given it a name. In this case, dept_av. Now, the main part of our query is super simple and clean. It just says select from dept_av where. It reads like a story, from top to bottom. The logic is identical, but the readability is a night and day difference.
So let's do a super quick recap of our journey. We started with aggregate functions like average and count to just summarize our data. Then we used group by to create those awesome category by category comparisons. We used having to filter those groups. We used subqueries to handle multi-step problems. And finally, we used the with clause to make it all clean and readable. That's the whole toolkit.
And there you have it. We've gone way beyond the basics, building up a toolkit that lets you ask some really sophisticated, multi-layered questions. You're now equipped to do some serious analysis. So, I guess the only question left to ask is, what are you going to go find in your data?